Earth's invisible guardian, the magnetic North Pole. Our planet Earth is a dynamic world, a sphere teeming with life and shrouded in an invisible force field, the magnetic field. This field, generated deep within Earth's core, acts as a shield against harmful radiation from the sun and cosmos. It's a silent guardian, protecting life as we know it. At the heart of this magnetic field lies the magnetic North Pole, a point on Earth's surface where the magnetic field lines converge vertically. This point, often depicted on maps and compasses, is not static. It's constantly on the move, a wandering point in a constant dance with Earth's inner forces. Imagine Earth as a giant magnet with its magnetic field lines stretching out into space, forming a protective bubble around our planet. This magnetic field is not perfectly aligned with Earth's geographic north and south poles. Instead, it's slightly tilted, and the magnetic North Pole sits at one end of this tilted axis. This difference between geographic north and magnetic north is what causes compass needles to point towards magnetic north, not true north. For centuries, explorers, navigators, and adventurers have relied on this magnetic pull to find their way across the globe. The magnetic North Pole is not just a point on a map, it's a dynamic force constantly moving and shifting in response to Earth's core dynamics. This movement is natural, a part of Earth's rhythm. However, in recent decades, scientists have observed an acceleration in the movement of the magnetic North Pole, a phenomenon that has captured the attention of researchers worldwide. This acceleration has led to a renewed interest in understanding the magnetic North Pole, its movements, and the implications of its wanderings. The magnetic North Pole is a fundamental aspect of our planet's dynamics, and its movements have far-reaching consequences for navigation, technology, and even the natural world. Charting the uncharted, tracking the elusive magnetic north. For centuries, the location of the magnetic North Pole has been a moving target, a point of fascination for explorers and scientists alike. Early attempts to map its location involved painstaking observations of compass readings and astronomical alignments. These early efforts provided a glimpse into the dynamic nature of the magnetic North Pole, revealing its tendency to drift over time. Today, scientists have a much more sophisticated toolkit at their disposal. Satellites equipped with magnetometers constantly monitor Earth's magnetic field, providing precise measurements of the magnetic North Pole's location and movement. The World Magnetic Model, WMM, a collaborative effort between various international organizations, plays a crucial role in tracking these changes. The WMM is a mathematical representation of Earth's magnetic field, regularly updated to reflect the latest observations of the magnetic North Pole's position. This model is essential for a wide range of applications, from navigation systems to geophysical research. The WM is typically updated every 5 years, but the recent acceleration in the magnetic North Pole's movement has necessitated more frequent updates. This increased frequency highlights the dynamic nature of Earth's magnetic field and the importance of accurate models for navigation and other applications. Imagine relying on a map where the landmarks are constantly shifting. That's the challenge posed by the moving magnetic North Pole. The recent updates to the WMM have revealed that the magnetic North Pole is drifting faster than previously thought, moving towards Siberia at a rate faster than any time in recent history. This accelerated drift has significant implications for our understanding of Earth's magnetic field and its potential impact on our technological systems. On the move, unraveling the mystery of the wandering pole, the Earth's magnetic field is generated by the movement of molten iron in the planet's outer core, a swirling mass of liquid metal thousands of kilometers below the surface. This churning ocean of iron acts like a giant dynamo, generating electric currents that in turn produce the magnetic field. The magnetic North Pole, the point where the magnetic field lines converge vertically, is directly influenced by these dynamic processes happening deep within our planet. The exact reasons for the recent acceleration in the magnetic North Pole's movement are still a subject of ongoing research, but scientists believe that it's likely related to changes in the flow patterns of the molten iron in the outer core. These changes in turn influence the strength and direction of the magnetic field lines, causing the magnetic North Pole to drift. Imagine a river shifting its course, carving new paths through the landscape. The molten iron in Earth's core behaves in a similar way, constantly reshaping the magnetic field. One leading theory suggests that a region of rapidly changing magnetic field beneath Canada is weakening the magnetic influence in that region, causing the magnetic North Pole to be pulled towards Siberia, where the magnetic field is stronger. This tug-of-war between different magnetic forces is thought to be a major driver of the magnetic North Pole's movements. Understanding the intricacies of Earth's core dynamics and their influence on the magnetic field is a complex task, requiring sophisticated computer models and extensive data analysis. However, unraveling these mysteries is crucial for predicting future changes in the magnetic North Pole's location and mitigating any potential impacts on our technological systems. In a world that is constantly changing, navigating through life can be quite the challenge. From shifting weather patterns to evolving technology, we are in a perpetual state of adaptation. Understanding these changes is crucial for making informed decisions and thriving in an ever-fluctuating environment. Our animal neighbors are not immune to these changes. Many species are experiencing shifts in their habitats and behaviors due to environmental fluctuations. For instance, migratory patterns are altering, and some animals are finding it increasingly difficult to find food and shelter. These impacts ripple through ecosystems, affecting biodiversity and the balance of nature. The implications of these changes extend beyond the natural world. For example, GPS systems, which rely on precise data, can be affected by atmospheric conditions. This can lead to inaccuracies in navigation and timing, impacting everything from personal travel to global communications. As we rely more on technology, understanding these potential disruptions becomes even more important. So, what can we do to prepare for the future? Predictions based on current data can help us anticipate changes and take precautions. This might involve developing new technologies, adjusting policies, or even altering our daily habits. By staying informed and proactive, we can better navigate the uncertainties ahead and build a more resilient world.